Hey there students, Mr. Fuga here. In our video today we're going to be working through an example scenario for Design Challenge 0A. Now Design Challenge 0A for this year deals with designing a ferry or a large ship used for transportation. So it may differ, the numbering may change up just a little bit depending on the year in which you're watching this video, but the context of our design challenge here is that we're going to be looking at designing a ferry. So the other title you might see on this is Finding the Finest Ferry. I know, great name, save your applause. Now what we're going to be doing here is we're going to be walking through a few of the main points of what we're looking at in the design challenge, and then we're going to get into actually practicing an example set of selections and walking through the scoring and how we actually will be working with the different components of the design challenge. So just a few things I'm going to encourage you to make sure you have out and ready as we're working through this. Number one, make sure you have access to the mission brief. I've printed out a hard copy here, so I've got that easier for me to look at. For you all, the mission briefs will be available on Canvas. On the assignment page, you'll see a link that will take you to the mission brief, which will give you all the main information that you need. So make sure you have that out. I would also suggest, before we actually get into some of the details of what we're doing here, that you take about 2 to 3 minutes and read through the first 4 sections. So the background, the situation, the objective, and the constraints. Those first 4 sections, making sure you've read those, which should take you about 2 to 3 minutes, will give you a good foundation and context. I'm going to be working through this video assuming that you've already read through those things, so I'm going to be hitting the highlights, but if you take the time to read through that, it will give you a really good foundation in what we're doing here. So, making sure you have the mission brief, you've read through those first 4 sections. I would also encourage you to have out probably a calculator, so you can work through some of the calculations on your own, as well as something to write with and write on. Again, it's one thing to see me work through the example, but it's another thing to do it yourself and make sure you're coming up with the same numbers that you see up here. So, kind of jumping in, and again, I'm going to be walking through this assuming that you've already read through those first 4 sections. So if you haven't, even take a moment now, pause the video, go through and read those first 4 sections. I know it may feel like additional time, but in the long run, it will save you time because you're going to have a better foundation on what you're doing. So, jumping on in, where are we actually going to start with our design challenge? Well, with Design Challenge 0A, we're going to be looking at designing a ferry. And in short, a ferry is a large ship that's used for transportation when things like roads and bridges aren't really feasible. So oftentimes to get out to an island, that sort of thing. They're not typically used for incredibly long distances. Most of the time, ferry trips are going to range somewhere between 30 minutes to several hours. So we're going to be designing a ferry, or as you can think about it, basically a ship. Now, what are some of the main constraints or the main important points that we're going to have to consider? Well, some of the highlights that you read about in the situation. Number one, we have to make sure that our ferry is going to float. That's going to be one of the number one most important things we have to check. How are we going to determine if the ferry floats? Well, in order to determine that, we're going to have to check the density of our ferry, which is something we've been learning about in class recently. Now, as we've talked about, density is a ratio of mass and volume. So when we start to look at some of the different parts of our ferry, we're going to have to look at how massive those are, as well as how big those are. And this will be one of the main things that we have to check, is to make sure that our ferry does in fact float. And as a reminder, when we're dealing with something like, well, when we're dealing with something floating, we have to compare its density to the density of the liquid that it's, well, resting in, or hopefully it's not submerged, but the liquid that it's in. And for our purpose, our density for water is 1 gram per cubic centimeter. So as long as we are under that density, we're going to be good to go. But that will be one of the very first things that we'll need to check, and something that you probably saw in the situation as well as in the constraints section. Now, some of the other things that we'll have to consider when we're setting up our design challenge, and some of these you read about. One of the other factors that we want to try and prioritize is we also want to make the most profit. So with our ferry, we're going to be selling tickets. And so the more tickets we sell, well, the more money we're going to make, which is a positive. Now, in terms of making profits, profit is going to come from, as I mentioned, the ticket sales. But one of the things that we'll have to look at when making profits is what we call the recreation area. So consider, what are the passengers going to be doing? So for the recreation area, we've got a few choices, and you'll see those in the appendix. One of them is we can have the passengers just sit in their car. Another one is we can build a lounge for the passengers, and then we can also have an arcade. Each of those are going to allow us to charge more money for the tickets, but they are also going to add more mass. So the upside of having Next Recreation is we can make more money. The downside is we increase our mass, which, as you can tell from our density formula, may in fact increase our density to a point where it would be unsafe. So again, those are going to be some of those competing interests that we talked about with our design challenge. Another factor that we'll have to consider is low fuel. Now, why is low fuel going to be important? Well, if you kind of apply this into the real world, the less fuel we use, that's going to cost us less money in the long run. Here, rather than doing a whole setup on how much fuel we use, how much money we pay for that fuel, we're going to have something in this design challenge that we call the fuel factor. Now, our fuel factor, and there's an equation that we're going to be using for this and that we'll introduce here in just a moment, our fuel factor is going to be related to the density of your ship. And you may be wondering, why are those two things connected? Well, remember, density expresses, at least for what we're dealing with for volumetric density, the density that we're dealing with here gives us an idea of what our object's going to do when it's, well, resting on or around a liquid. And so we want to make sure that our ship is less dense than the water that's going to be in, otherwise that would be a bad thing, the ship would sink. But beyond that, do we want the density to be like right up close to 1? Would that be a good thing or a bad thing? Well, as you might imagine, if we have the ship mostly submerged in water and there's just a little bit above, we're still under the threshold of 1, which is good, but a lot of that ship is going to be submerged, which means we're going to have to be pushing a lot of the ship through the water. There's going to be a lot more resistance and drag coming from the water. Now, if we have the density of the ship a lot lower, let's say it's 0.6 or 0.5, that means a smaller percentage of the ship is going to be submerged in the water, which means we're not going to have to burn as much fuel because there won't be as much resistance from the water. So low fuel is a good thing because it's going to minimize our density. And so finally, what you'll see later on in our scoring formula is our scoring formula balances these two factors. We want to have the most profit we can, but we also want to minimize how much fuel that we're going to use. So those are going to be the two main factors that we're going to be looking at. Now, a few other things that I want to mention, and if you actually look at the mission brief, you'll notice that it might be a little bit hard to see it here, but again, hopefully you've got it and have access to it. I'm going to look at the appendix section now. Now, the appendix section gives us the three main choices that we have. The first is what we call the hull. This is effectively the body of the ferry. Now, the way these design challenges will work is that you're going to have some options that you'll be choosing from. So with the hull, or the body, you're going to have three options: the minnow, the dolphin, and the orca. Effectively think of them as small, medium, and large. Now, with each of those different hull options, you're going to be given four pieces of information: the mass, the volume, the cost per trip, and the maximum number of cars. A few things here. Obviously, as you can tell, the bigger the hull gets, the more mass it's going to have. That's a bad thing because the more mass we have, the higher our density is going to be. You'll also notice that the more mass we have, the larger the ship is, which is a good thing, so it may balance out some of that mass. You'll also notice the cost per trip. So you might imagine the smaller ship is going to cost us less money to operate, the bigger ship is going to cost us more money to operate. So we want to make sure that our mass and volume give us a density under 1. We want to try to minimize our cost for the trip, but we may actually see that in the long run, maybe it's better to go with the orca. We don't know yet until we actually start to work with some of the numbers. Now, lastly, this maximum number of cars. This is the number of cars that can fit on the ship, or the ferry, but you don't have to go to that maximum number. We do have to make sure we don't go over the maximum, but we can always go under that maximum. And you may be asking, why would I go under the maximum? Well, if you notice that your density is just slightly above 1, and rather than having to go through and rearrange all of our choices here, we might just drop our number of cars down by 1 or 2 to help balance some of those factors out. Now, I will remind you that our number of cars is also our number of tickets. Every car on the ferry is a ticket. So people buy a ticket, they bring their car onto the ferry. So the fewer cars we have, yes, that's going to drop our mass, which will in turn drop our density, but it's also going to lessen how much money we make, which is a downside. So as you'll notice here, a lot of these factors, they can kind of be connected, and as we increase one thing, it may decrease another. Now, I kind of alluded to our next set of components, our next component, the recreation area. Here are our three options on recreation, just as an overview. We have just the cars option, which means the passengers on the ferry ride in their cars, so they just sit there and hang out on their phone, I guess. That's not going to add any additional mass to the ferry, and we're going to charge a lower ticket price for that. The next option would be a lounge, where passengers can go and hang out. That's going to add a bit of mass, but we are going to be able to charge more. And then finally, we'll have a full-scale arcade, imagine TVs, maybe a little mini restaurant in there, and we'll be able to charge a lot more for those tickets. Again, the downside with the recreation is we're adding mass, but the upside is we can charge more and make more money. Now lastly here, and this is a bit of a small addendum, the number of cars. This is a choice, but it's going to be based off of the hole that you choose. So remember, you can go with the maximum number of cars, but you don't have to. You can always drop your number of cars down if you're trying to adjust around the mass. One thing I want to remind you about, each car has a mass of 3 million grams. That would be 3 times 10 to the 6th grams per car. And so that will be something that factors into our formula as we go forward. So these are the main things that we're looking at here with our design challenge dealing with the ferry. Now what I'm going to do here is I'm going to walk through an example of a few different selections. Now what I'm going to be doing is I'm going to be kind of making up some choices. These are not going to be choices that necessarily show up in the components that are available to you all. What I'm trying to avoid in doing is I don't want to just show you all one of the solutions and then just have everybody pick that one because they see me do it. But I'm going to walk you through how you'll go about using the scoring formula and finding out how good of a design you actually have for this challenge. So, in order to start these, that's oftentimes a big question that we have is where do we actually begin? Well, you're not going to know how effective your different combination of choices is until you actually run through the scoring formula. So I tell people oftentimes, just make a choice, just choose some options. Don't stress too much about what those options are initially, just choose them. And then work through the scoring formula. You're going to get some practice on how to work with that. And then once you do, you'll get a number out, and that will tell you, oh, this is a good set of selections. This is not a good set of selections. And then you'll have some choices on how you'll go about improving things. So, here are going to be the choices that I made. I'm going to choose a hull. I'm going to call this hull X. Because again, this is not one of the hulls that's available for you all. Now, hull X, a few things about hull X. It has a mass of 80 times 10 to the 6th grams, so 80 million grams. It has a volume of 180 million cubic centimeters. Times 10 to the 6th is on the order of million. We've got a 12 car max. And a cost per trip of $90. Okay, and then my recreation option, I'm going to choose recreation X. Again, this is not one of the recreations available for you all. This is just a random one I'm making up. And that recreation option has a mass of 20 million grams and allows us to charge a ticket price of $80. Again, just to be clear, these are not options that are available for you all. Now, the last thing I'll clarify is that I'm actually going to go with the 12 cars. Again, you don't have to max out your number of cars, but I'm going to start with, you know what? I just want to make as much money as I can, and hopefully the mass and volume will work out. If they don't, I'll have to deal with that a bit later and kind of revisiting my selections. So, once you've made your choices, and again, you'll notice that will take you a minute or two. Just make a choice. It's fine to discuss some of the options together, but don't be paralyzed in trying to find the perfect solution before you actually run through some of the numbers. It's really best to discuss for a few minutes with your group or who you're working with, and then ultimately just make some choices and start working through the formula. Right? The quicker you get going on actually working with the numbers, it's going to give you a better idea on what things are most important in the design challenge. So once we've done this, the first thing that we'll do is we're going to check density. Does our ferry, actually float? Because if it doesn't, then I'm going to have to go through and revisit what I'm doing here. I may just drop my number of cars down so it decreases the mass a little bit. But that's the first thing we want to check. Now, how are we going to find our density? Well, remember, broadly, density, for our purpose, is a ratio of mass to volume. So what we need to do is we need to kind of tally up, add up all the mass on our ferry and look at its total volume. Now, the volume will be a little bit easier because we're just going to use the volume found in the hull information. But with the mass, we have to include several different things. Now, on your mission brief, you're going to see a formula for density that looks a little bit more complex, but it's really just this ratio of mass to volume that we've been using. It looks like this. Density is equal to mass of the hull plus mass of the wreck plus 3x divided by the volume of the hull. And all this formula represents, is over here, is the total mass of everything on our ferry, the hull, so the ferry itself, the recreation center that we put on the hull, and then 3x. What does that 3x represent? Well, remember that every car has a mass of 3 million grams. So the 3 represents the mass of one car, x is the number of cars that you're working with. So here's what we've got. Our hull, and I'll double check here, mass of 80 times 10 to the 6th kilograms, so 80 million grams. Our wreck was 20 million grams, and I'm going to put 12 cars on the ferry. So here we go. We've got, putting everything in, we've got density equals mass of the hull, so 80 times 10 to the 6th grams, plus mass of the wreck, 20 times 10 to the 6th grams, plus the cars are 3 times 10 to the 6th grams multiplied by 12, divided by the volume of the hull, which was 180 times 10 to the 6th cubic centimeters. Now you may notice that all of these values are on the order of 10 to the 6th power, which means to make the math a little bit easier, you can actually kind of divide out that 10 to the 6th power. So rather than treating this as 80 times 10 to the 6th, I can just treat this as 80, 20, 3, and 180. I'm dividing out that 10 to the 6th power from every term. Now I couldn't do that if I didn't have the same power everywhere. I can only do that because all of these values are on the same order. So it's still the same as a ratio of 80 to 20 to 3 to 180. So it makes the math a little bit easier for us to work with. So adding together the values in my numerator, 80 and 20 gives me 100. 38 multiplied by 12 is 36. So 100 plus 36 gives me 136 grams divided by 180 cubic centimeters. Now again, the ferry has a mass much bigger than 180 grams and a volume much bigger than 180 cubic centimeters. But it's equivalent to this ratio. So I'll plug these in, 136 over 180. My numerator is smaller, so I should be good here. And I'm getting 0.756 grams per cubic centimeter. And that is a check mark because our value for density is less than 1, so we're good to go here. So that's the first thing we'll do working with Design Challenge 0A, make sure our ferry actually does float. Now, next, we're going to move into calculating something that we call the fuel factor. Because the fuel factor is something that we'll need in order to determine our final score. As I mentioned earlier, our fuel factor is going to be based on the density of our ferry. And we've got a formula that goes like this. 80 multiplied by our density Q. As you can imagine, the higher our density, the higher our fuel factor is going to be. Again, the more dense our ferry, the more it's going to sink down into the water, and the more fuel we're going to have to use to power the ferry forward. So our fuel factor should be pretty straightforward. I'm just going to plug in the density we just calculated, 0.756. Our fuel factor doesn't have any units, so I know our density is in grams per cubic centimeter, but we don't need any units for our fuel factor here. So 0.756 to the third power, multiplied by 80, and I get a fuel factor of 34.57. Now that number is not going to mean anything to you, and that's okay. The obvious goal for the fuel factor is we want to get it to be as low as possible, but it's probably always going to be bigger than at least 1. And so lower the better, but for now we're just going to look at how we calculate that so that we can use it in our final score formula. Okay, so lastly now what we'll do is we'll move on to how we calculate our final score. Now, as I mentioned in one of our previous videos, the scoring formula is going to be different for every design challenge. For this design challenge, as we talked about, our two main objectives are we want to increase profit, make as much money as possible, and decrease fuel consumption. So our final score formula looks like this. We take the ticket price, and we multiply by the number of cars. We subtract the cost per ride, I'm just going to write cost, and then we divide by our fuel factor. Now, really these formulas are kind of just things that have been made up by Mr. Sanchez and I. He does a lot of the heavy lifting on these, and he's great with that. And so really we kind of talk through and kind of play around with how we can set up different formulas for each of these. So they're not always going to look the same, but there is always going to be a meaning to them, and I do want to make sure we understand how this is set up. You'll notice that everything in the numerator deals with the dollar amount. Our ticket price multiplied by our number of cars, that's going to give us the total profit we make, right? If I have 10 cars and it's $100 a ticket, well, that's $1,000. That's how much money I'm bringing in. Then I have to subtract out the cost. Imagine how much money we spend just operating the ferry on a trip. So really the numerator represents what we would call our net profit, how much money we're making on one individual trip. The denominator is our fuel factor. As we talked about, we want our fuel factor to be low. In any equation, in order to get the output of our equation to be high, so if we want our score to be high, we can either do one of two things. One, we can increase the numerator, right? So I can up my ticket price, up my number of cars, or drop my cost. All of those things would help improve my final score. Or I could drop my fuel factor. I may have a pretty low numerator, but if I take a low numerator, number in the top, and I divide by a really, really low denominator, I might be able to get a really good score in the long run. So when you're actually looking at playing around with this and trying to decide which set of selections might be best, there are two things you might consider. How can I increase the values in the numerator, or how could I really decrease the values in my denominator? So that being said, let's plug our values in and see what we've got. Now, I believe our ticket price was $80 a ticket. Let's double check. Ticket was $80 and the trip cost $90. Okay, so we've got, hold on just a little bit here. Ticket was $90. I chose to max out my number of cars, aka my number of tickets. So 12 tickets. The trip cost $80. Oh no, I'm sorry, I have those backwards. The ticket is 80. The trip itself is going to run us 90. And then I'm going to divide by the fuel factor that we just calculated, 34.57. That point is not very good. Oh no, not 517, not connected. Struggling. 5.7. Okay, so now I'll plug all this in and see what our outcome is. So, so $80, $12 a ticket, minus $90, divided by 34.57, and I get a 25.16, so I'll round it to 25.2. So, here would be my overall final score for this set of choices. Is that a good score or not? Well, for most of our design challenges, the ideal or the best score is going to hover around a 100. So for what we're doing here, this wouldn't be a great score. As I mentioned in some of our previous videos, this does not mean you would get a failing score on the assignment, because the goal is not necessarily with these to get a perfect score. It's to work on application, so applying what we're learning, and then also optimizing, trying to work on improving our outcomes. So from here, what would we do next? Well, now we would try some different solutions. Maybe I want to lower my fuel factor, which means maybe I lower my density. So maybe I take a little bit of mass off the ship. Maybe I drop down my number of tickets. That could be a good way to go about this. I may lose a little bit of money there, but in the long run, if I can drop my fuel factor down, I may actually be able to get a better score. You're going to notice that when you're messing around, no, I shouldn't say messing around, but you're going to notice that when you're working on improving your outcomes, when you're trying to get the best solution, you may in fact notice that one of your categories is going to decrease or look worse, right? Meaning, oh, maybe it's a bad thing for me to drop my number of cars because I'm losing money here, but in the long run it might be better because if I get a lower fuel factor, I may actually get a lower or a higher overall final score. And so I'm going to encourage you, try a lot of different things here. Discuss with your group. It's okay if, as you're working with a group, that you and the group have different paths that you're going on. It's okay to diverge and say, I'm going to try this, you're going to try that, and we can meet together and see how things go. The important thing is that we're ultimately always trying to work on making an improvement and having a good grip on what we're doing here. So hopefully this gives you a pretty good idea here on the overview for Design Challenge 0A. As always, if you have questions, please feel free to reach out and let me know. Other than that, good luck.